All right, so there you go. So GEO's 360 or 36, I think it's 360 for construction. And then that's my name. A couple of guys wanted to go and steal some. Okay, they were not going to steal, but they went to a lab to, go and spy on what they were doing in the lab. So they disguised themselves and they wore a lab coat. So as they entered the lab, the real lab technicians entered the lab. They couldn't recognize that these guys were actually spies. So, but then they had worn the lab coats for people who had not come to work that day. And one of them saw, one of these spies, and they were like, "Mr. Takanoshi." And he said, "What did you call me?" He said, "I called you Mr. Takanoshi." And then the guy immediately remembered that the coat that he's wearing has the name Takanoshi written on it, So he said, "Oh yeah, that's my name, Mr. Takanoshi." So for a moment he had forgotten his name, So yeah, but I haven't forgotten mine. And I'm not Mr. Takanoshi. I'm Mr. Ochu, Mr. Franz Ochu. Is that okay? I'm sure you're going to have a good time together. Can you mention your names and introduce yourself? Because even the class rep, I forgot, he's called me earlier on, but I didn't keep the name. Class rep, so you are Thomas, right? Are you Thomas?
Yeah, Thomas Kujama.
Okay, nice. Okay, so let's introduce ourselves. Just mention your name and where you work, or what you do, anything that keeps you busy from your end.
I'm Thomas Kujama. I'm a facilities supervisor at the Methodist Church.
Okay.
So I'm Richard Jojo. Asankuma. I work with Urban Road, Cape Coast.
Okay.
I'm Enoch Adamti. I'm Ghana Highway Authority. Who?
Okay. Nice. So Richard, Thomas, and Enoch, it's good to join. It's because your class is small, so that is why I got it quite emotional early on, because immediately you have a few people not present. It seems, nobody is around at all. So take note of the fact that you have a very small class. Okay, your class isn't that big. All right. Let's go straight to the point. These Zoom meetings, online meetings, has to be combined with the e-learning platform. I believe you all know the CAF e-learning platform. Have you all registered on it? Okay, so yeah, please make use of the assignments that are put on there, and you'll be fine. Do them. I'll probably not tell you I'll put an assignment there. From time to time, just check. I think that's the way it works. Otherwise, then I have to be telling you I'll put something there and those things. So you'll be checking, okay, the online platform to see if there's something on there. These Zoom meetings always last for 40 minutes. And I think we've already spent 17 minutes. Okay, so we left with how many minutes? 23 minutes, right? So you can see we've actually spent almost half of the time doing nothing. Okay, but it's okay. It's because it's the first time. All right, so yeah, this course is very easy, but it depends on how you look at it. If you do everything that you're supposed to do, I think it's going to be fun. Are you okay? It's going to be fun. But if you don't do everything you're asked to do, it's going to be, because it's going to look funny. In fact, you can even fail this course. Normally, you shouldn't fail GIS, but if you want to, you can fail it. It's optional. Okay. All right. So GIS. I think we all know what GIS. We've heard about it. And most people have actually heard of ArcGIS. They've seen people use ArcGIS, or they have used ArcGIS themselves. Okay, so it's a very popular software, and people talk about it. They say I've used it. Say I have these lectures And then there's always someone in the class who's probably even used the software before. And, you know, at the end of the lectures, then you ask him again, you ask the person again, is that what you were expecting? And you realize that no, that wasn't exactly what you were expecting GIS to be. So we need to understand what GIS is. Is that okay? GIS for. So what does a GIS, what does it stand for? GIS actually stands for Geographic Information Systems. Geographic Information System. And Geographic Information System means that there are other forms of information system. We can have management information systems. Okay, we can have content management systems. There are a whole lot of systems out there. Okay, but the thing common to all these systems is that we have it solves a problem within a certain area. Are you okay? So for GIS, we are looking at geographical problems that have a geographical dimension. Are you okay? So if you don't have any geographical or spatial dimension to it, so instead of you using the word geographical or geographic, you can actually say spatial, or you can also say locational. Okay, so these words can be used interchangeably. So anytime you have a locational component, let's look at taxi drivers. Taxi drivers were used to actually pick us, you know, on the roadside. We walk to the roadside and then they will look at the type of shoe you are wearing and look at your appearance, and then they'll pick you and charge you any amount that they wanted. Are you okay? And then sometimes you tell them that I'm going to North Legon, and you know, you get there and then they're angry because the charge was so bad, not knowing that soon that problem was going to be over, and then Uber is here and we are all enjoying Uber just like that. Are you with me? That is GIS for you. That is what GIS always try to solve a problem that has some kind of geographical dimension, where the question of where, anytime you're asking the question where, you should know that it's GIS that you need. Are you okay? Because systems are there to solve a problem. I keep saying that when you look at something like a sound system solves one problem. I want to produce sound. I want to hear someone. Sound systems is I'll do that for you. I'll let you hear a sound. But then when you look at a sound system, it's made of different parts. So GIS is made up of different components. Are you okay? GIS is made up of, you know, different components. And so we need to recognize that. Okay, so that is why GIS is needed. It solves a fundamental problem. Sometimes we can talk about the values, so many values. You can talk about GDP, you can talk about inflation and all that, but you can't really relate to it. The question is where is it happening? What are you talking about? You say a country is poor, but you can't even relate to which part of the country is poor. You are poor, Ghana is poor, but you see, you have to check your own individual, the particular locality, are you okay? And get to know what is happening there. Otherwise, you'll be generalizing. If you go to Trasaco, you know, they probably don't even know about, you know, rough roads, etc. I mean, they don't even feel all that. Someone can drive their car, they will never drive through mud throughout the week, throughout the months and the years. Are you okay? So they don't experience what you are talking about. Pothole doesn't mean anything to them, but we all live in the same country. So we need to understand that there is a locational and a spatial component to everything that we do. Are you okay? So gold doesn't exist everywhere. Think about it. Okay, gold doesn't exist everywhere. So that's what a GIS is there for, to tell us where things are happening so that we can keep track. Okay, a lot of drivers thought that they were very smart. They will get a truck from, you know, their masters, and then they're supposed to pick up some, you know, container from the Tema Harbor to northern Ghana. Are you okay? And they say, this man, he doesn't know. I'm going to give birth to, you know, I'm going to impregnate 3 women on my way. So they set off, travel a long distance. Only God knows that they're not even like being honest about this journey that they are taking, these drivers, truck drivers. You know, so in the past, for so many years, we heard it. Truck drivers, well, they have kids everywhere. That thing is a thing of the past. These days, if you try that, you come back home and they will sack you because you were tracked. And we know exactly where you were at any particular way. We know how many days you probably spent at one village. Are you okay? Enough to, you know, get you that baby. So things have changed. GIS is a new technology that has come. to help all of us. It's used in construction sites. Sometimes some construction sites are not, it's not 2x4 construction site, 10 meter by 10 meter construction site. Construction sites span large areas. Are you okay? They span, not just a small manipulable space, but then they go beyond that into environmentals. We can look at a large area of construction going on. And you can actually work on a site. I mean, I've worked at Heathrow Airport before, and where you work on the site, the same project, but where you work on the site, there's a bus that takes you there. So that the bus drops you here, a welder here to do some welding, and it drops me somewhere else, and we may never meet during the day, but it's one project that we're working on. Okay, so we need to appreciate that geography is actually a part of our lives. In fact, it's everything around us. And a geographical information system is key, and everybody needs it. It's like, and that is why construction, you are doing it. Okay, and I believe everyone should do it. Medical doctors should do it. Farmers should do it, because we talk about what we call precision agriculture today. You just don't go out planting. Are you okay? I remember when we used to plant, and in our small garden, some parts of the soil, you realize that, Charlie, this part I'm planting corn, the corn will survive. And yet we are planting it there, hoping that it will work, like it will germinate and it will go, but it doesn't work. And the funny thing is that something will survive there, but not the corn. So we can look at applications in agriculture. Are you okay? I.e. in precision agriculture, you can look at telecom. Sometimes you are actually in the same house with someone, and you make a call, and you are told that the phone is off. Are you okay? Network coverage in terms of telecom. All that is because probably the mast hasn't been placed well, so the location comes in. Are you okay? And we can talk about military. Military, they don't go there. In fact, I sometimes I watch some military, scenes, where people are fighting, and realize that where you are is really like key. You get killed or you survive. Where you are. The question is where you are. So the military, they need GIS more than anyone, because your safety depends on where you are. Where you have passed will determine whether the whole, the troop get killed, and or your survival depends on where you are, how high or low you are. So GIS looks at the military part, where they should pass their routes. Are you okay? Where they should set up the equipment, how they should deploy. GIS take care of that as well. In forestry, you can't be minister for forestry or whatever, and then you are out there driving your 4x4 just to monitor who is cutting what tree. No. There are satellites up there that will give you enough information for you to track and say that, well, we believe that so many trees have been cut without you going there anyway. But so all that is actually what GIS stands for. Okay, so I'll go back to, this is what I'll be doing from time to time. I'll go to my whiteboard, and from time to time I go to my presentation, to my PDF. Okay. So the things that you need in this course are, normally I have a handout that I give out. Okay, it's for sale. So if you want it, you let me know. I think one is 50 cedis or so. I mean, honestly, you need to just buy it. It's not, because of COVID, we have not stopped selling handouts, please. Okay, so take note of that. We will do a practical, so take note of that. And all of you should install a software. Always, this will be the first assignment to the whole class. You need to install a software called QGIS, which stands for Quantum GIS. So look for the latest version of the software, stable version for your OS. Okay, look for the stable version, not the latest version, the stable version. Sometimes the latest version may not be, but obviously get the latest version, which is stable. All right, and then let's use it in a practical. I will tell you when to get it ready. When the time is up, I want all of you to have it. Please take note of it and do it. All right. So Quantum GIS, since I'm recording it, you can play back and see, if you couldn't write it down. Okay, I'm going over some of the things I talked about. GIS stands for Geographic Information Systems. So there's geography in there, there's information system in there. So you can just combine information systems. Okay, so but information system means that we have so many parts. Okay, working to produce information. All right. GIS geography bits means that anything at all. So please, I won't just be talking about construction and I'm talking about construction. No. I will talk about anything possible. Think about elections, think about COVID, think about, engineering, anything at all. So it's assumed that you are, level-headed to a certain extent you can appreciate. Lands, geography is about lands, it's about features or things on it. People is about people. So we are talking about these things, okay, in geography, objects, etc. Places, spaces, people, location. That is what geography is about. Take note of that. Okay, geography is about that everything. Like when I talk about clouds, you should know what clouds are you okay? Know a little bit about clouds. I mean, if you still feel that clouds are so high in the sky, then you need to go and pick a local flight. Are you okay? That's cheaper. Travel from Accra to Kumasi and you get to know that clouds are not that high. Are you okay? You should know that. Also, lakes don't flow. Lakes are still. Okay, take note of that. So rivers flow. Rivers are always flowing. All right. So these are geographical, stuffs. When you see a group of people gather somewhere, for example, here this is like a fishing harbor of a sort. Okay, people are actually, selling, bringing fish. People are buying fish. So that's an activity. Okay, an activity going on the surface of the earth. Phenomenal. I can talk about something like the wildfires in Australia or Canada. Every year they experience these fires. They are in the advanced countries, but they can't control the fires every year that engulfs their forests. Okay. So that is a phenomenon. Are you okay? That's a phenomenon. So when you look back at that definition, then you can see that geography looks at phenomenon. Are you okay? Not just objects, but phenomenon. Okay, so we need to appreciate that. Geography touches on altitude as well, or elevation. Are you okay? So Ghana lies between latitude 4 degrees 11 degrees north of equator on the west coast of Africa. Ghana is a low land country. You need to appreciate the elevation as well. So it's not just the planimetric location of things. Okay, we are interested not only in where something is, but we want to know how deep. Are you okay? How high that place is. So x, y, z. So the x, y, let's say if this were y and this were x, okay, we can locate this place with the x, y coordinates. Are you okay? But then how high it is, we have to then add a z. Are you okay? So we need to recognize that geography should look at how high and low places are as well. I mean, it's not a big deal. It has to be said. I have to quickly say that. A few things that we don't know about information is that information is not data. Is that okay? Information makes sense and is derived from data. Are you okay? A system is also a group of interrelated parts. They're working together to achieve a common goal. Okay, it's very important. And I think I've touched on all these things here. That it's very important to track events that are happening. Okay, all right. So yeah, basically this is the course. Is okay. We'll be talking about definitions and concepts of GIS, okay, in this course. We're talking about data sources and acquisition. So in every information system, you need to first go and get the data and convert the data into information, transform the data into information via the computer. So the computer is what does the actual information, transformation. So we need to first get the data. And so we talk about different types of data acquisition. We'll talk about even land surveying as a data acquisition method. We can talk about GPS. We talk about remote sensing. Okay. And we'll talk about photogrammetry. And then we also recognize the fact that you don't have to even know about all these data acquisition methods as primary data acquisition methods, but you can actually buy the data from another company. Are you okay? So there are companies that simply acquire data and then they sell it. Are you okay? All right. All right. So we look at methods of input, digitizing, are you okay, manual entry, and etc. I think these are the two basic things we talk about. Data structures and data models. Here we're talking about GIS is all about the data model. Okay. When you look at GIS and look at CAD, okay. So CAD is computer aided design, and one of the most popular software using CAD is actually AutoCAD. Are you okay? So I believe construction students, you've used AutoCAD before. So computer aided design software. Okay, so example is AutoCAD, because there are other ones, okay, that may not be, but AutoCAD by Autodesk is very popular. Is that okay? Let's say they have actually advertised it a lot and they have invested more into it. And so AutoCAD has become like a household name to every engineer and every builder. Are you okay? So there we go. We'll talk about the data model. In GIS, the data models are raster data model and then the vector model, vector data model, or the vector data structure. Is that okay? All right. So there we go. Concept of map projection. We'll find out that, okay, since the world is not flat, as we found out, okay, we have to now change the data that we have from a spherical surface onto a flat surface. So that concept will be dealt with under concept of map projection. Is that okay? So I'll talk about map projection when we get there. When we cross that bridge, we will cross it. Is that okay? Map projection. How do we convert data into, in fact, if the map projection also touches on coordinate system. So we need to also know that. All right, so the earth is not flat like a pancake. Is that okay? We have 10 minutes. When the 10 minutes is up, please kindly rejoin. But the earth is not flat like a pancake, but it is round as an apple. Are you okay? So the map projection is what is helping us to convert the so-called longitudes and latitudes into XY coordinates. Okay, so every time you are holding a sheet of paper, a flat sheet of paper, and then you are actually working on the site and you are doing, always remember that there's a lie somewhere. Are you okay? You have actually made it's an assumption and there's an error in there. Okay, because the world isn't flat. How can you be having it on a flat sheet of paper? Are you okay? You should be having a portion of a round thing. Okay, so we will look at map projection. Basically, map projection and coordinate systems go together. We will find out, even in the map projection, whilst we are looking at it, that we are dealing with spherical coordinate systems versus the Cartesian coordinate system. Is that okay? I know it may not make sense to you, but let me start saying something about it so that when we get there, it won't sound like a total, strange thing to you. But obviously, we all heard of longitude and latitude. So I don't think this is totally strange. Okay, this is longitude and latitude. And this one is what we know from, JHS or SHS or I don't know, O level, or it depends on where you're coming from. Are you okay? All right, so that is map projection for you. We'll talk about that in these lectures. So don't miss it when we get there. Don't tell me you can't get a good network. All right, there's continuous assessment. So anytime I say do something for me, just do it. Because remember that it's my opportunity to just dash you some marks, about 30 marks or 40 marks. In fact, I think we really looked at this percentage, this proportion, this allocation of marks. I think it became 60-40. But yes, take your continuous assessment seriously so that you go to the exam knowing well that you already have some 25 marks somewhere. You are only going to work for some, 40 marks out of 70. That means you didn't do well. Then you'll be getting 65. So if you didn't even do well in the exam, then you have 65. But if you go in the exam, you didn't do the things you were asked to do, you are going with 0, going to face the exam 100%. And trust me, people don't do well in exam normally. They don't. A lot of people don't. Okay, not my class, but generally, exam always make it is challenging compared to continuous assessment, which you are supposed to just do it at home. Are you okay? All right, guys. So this is what GIS is about. If you've heard of it before, and I'm still talking about it, and it's sounding like something you haven't heard about before, or if you are thinking GIS is something that you think maybe it's not what it's supposed to be, you can tell me. Otherwise, I think when this Zoom meeting ends, I will continue. I'm going to start, I'm going to continue with what I'm doing. And so, but then I want you to ask if there's any question you want to ask. I want you to ask him now before I continue. If you have a question, yes.
Concerning the handout, you say you WhatsApp it to us by so much.
Please, I want questions on my lecture. I always want questions on the lecture. As for these questions, I can answer them on WhatsApp. So please, now is a lecture question, please. Lecture. I want the understanding is more important to me. Okay. Did you understand everything I just talked about? I've introduced GIS to you. Do you think you get it? If you get it, are you ready for a question when I ask you a question? Okay, great. So let's move on. So please, we'll talk about a handout, like maybe on WhatsApp. Is that okay?
All right.
And do a whole video WhatsApp video call with you, and then we talk about it. Okay, so the presentations I'm giving you, they are from this website. So if you want to go and get it, you can just go here. I created it myself, it's free. Free website creator. So all my presentations, all the lectures that I do, this is where I've dumped most of them here. The presentation. These are like PowerPoint. Is that okay? All right. Great. GIS definition. See how many definitions we have? 3. And the question is why? Why so many definitions? Even one definition I can't keep in my head. And then you are giving me a category of definitions. And the reason is because GIS is, people love GIS. Everybody want to have a portion of it, a cut of GIS. It's so cool. Even today, look at Uber. Everybody is on Uber and they just using it. And it's GIS. Uber is GIS, and I'm happy that Uber came. So you can even have a question on Uber in exam. You never know. All right. So there are 3 definitions. We have the toolbox definition. We have the database definition. We have the organization definition. Let's look at them one by one. Toolbox definition says that why don't you consider GIS to be a toolbox? Okay. So a powerful set of tools. We have them inside that box. And then you can use those tools to collect, you can use it to store, and then you can use it to retrieve a world, transforming and displaying the spatial data from the real world. So the keywords are that the GIS should help me not only to get data on my things that are happening around me, it should help me to work on that data, transform it, do a whole lot with it, do map projection if you like, change it into a different form. Say, I can even pick, say, spot heights. I hope you've done some landscaping before. Pick points with their heights, and then GIS should be able to work on it and convert it to something else. So that transformation should be able to do that. GIS should help me to now visualize, are you okay? Or to display the geographical data. So not only do I collect data on rivers, I should be able to see the river. Oh, okay, there it goes. That's the river. Are you with me? So that is the toolbox definition of GIS. Let's look at the database definition of GIS. So database definition, first, you need to know what database is. Database, we talked about database in Ghana too many times. We're going to create a national database, and there's a database, a health database, and all the NHIS database, and all that. What is really a database? Database really is an organized collection of data. Is that okay? So with IT, in information technology, IT is really one of the big topics in there. And what database definition touches on, let me just read it out for us. It's a database, a system in which most of the data are spatially indexed because indexing is something that happens in most databases. It has to be indexed so that we can easily query it. All right. So most of the data are specially indexed, and upon which a set of procedures operated in order to answer queries about special entities in it. So the database contains entities. In fact, every database contains entities, but this particular database contains special entities. In other words, I can put some like a tree in there. I can put a building in there. I can put different types of objects in that database. But then on top of that, what I can do is I can query it. Are you okay? So we watch a movie in which, you know, you have the killer being tracked by some IT guru somewhere, and it's like he's gone down south and all those things are GIS query. Are you okay? So queries are very important, but GIS queries, they are very powerful, and they are because they tell you where something is happening. Are you okay? It's not good enough to just say there's a thief in Medina. I mean, where do we find him? Are you okay? But if you say he's gone to, you know, Atomic Junction, then we know what you're talking about. All right, so organizational definition of GIS. Look, this definition, the motivation of it is from an organization that already keeps its data. Then you introduce GIS to it. How would they see the GIS? They will see it as an automated set of functions that provides professionals with advanced capabilities. You know, advanced. They're looking at it to be very, very advanced capabilities for storage, retrieval, manipulation, and display of geographically located data. Osmoy, Smith, and Six. So people have come out with these definitions. Are you okay? They wanted to, because GIS is new, like relatively new. GIS is not like, can you imagine this was said in 1981? Are you okay? And so you can imagine relatively, you know, it's like computers, when were the first computers made? So relatively, GIS is a new technology. We don't want to call it something that has been in there for a long time. All right, so these are the components of GIS. I told you that every system has different parts. Okay, so these are the parts of GIS. These are the components of GIS. Don't say the parts, the components of GIS. There are 5 of them. We have the hardware, we have the software, you have the data, you have the people, you have the methods. This is so easy